In this lecture, we're going to discuss NAT, Network Address Translation. It's a very interesting technology which allows you to use public IP addresses without actually owning them. NAT stands for Network Address Translation. It is used on network gateways and offers the following. The biggest advantage is that it allows the use of a single public IP address to handle thousands of internal systems. So let's say you have a company and you have thousands of internal systems and you want all of those systems to be publicly routable, which basically means that they are able of communicating over the internet. So then ideally you should be able to purchase thousands of public IP addresses, but IP addresses are expensive. So NAT is a perfect solution which allows you to use a single public IP address and still support thousands of internal systems. It also allows to hide the IP addresses of internal systems. So this is an added security advantage that whatever IP addresses you're using internally, they will be hidden to the outside world. Another advantage of NAT in terms of security is that it does not allow external systems to initiate communications to internal systems. So basically, if you have a system which is inside your corporate network, it can initiate a connection to an outside system, but the converse is not true. NAT hides the internal details so that any outside or public system is unable to find out the exact IP addresses of internal systems, and hence they cannot initiate a communication. Let's see how NAT actually operates. So let's say this is your corporate network, and if you note, you're using private IP addresses. So for example, 192.168.1.2 or 192.168.1.3, they're all private addresses, which basically means they're not publicly routable. Now let's say you want to send data to this system, which is on the internet, and it has a public IP address of 202.12.13.4, and it has an application running on port 3000. So what you do is that you create a packet, you put your own IP address as the source IP address 192.168.1.2 and your own port number, source port number 2000. And obviously in the destination you put the destination IP address and the destination port number. And then you send this packet to the NAT router. So an interesting thing happens when it arrives at the NAT router. So the NAT router has a public IP address 96.9.9.3. This is a publicly routable IP address. What the NAT router does is that it maintains a table. It simply copies your source IP and port number, and it notes down that it's going to replace this with its own IP and a randomly generated port number. Let's say 6000. So what it does is that the NAT router is going to craft a new packet. And if you note, it has changed the source IP and the port. It has replaced the original private IP address and port number with its own publicly routable IP address and port number. And then it sends this packet to the destination. So from the perspective of this destination, it thinks that this packet is coming from this NAT router because you see, it only sees its IP address and port number. So naturally, when this destination is going to respond, it's going to put its own IP address and port as the source, and it is going to put the IP address of the NAT router, which it saw previously in the header, and the port number, and then send this to the NAT router. So when the packet arrives at the NAT router is simply going to check, what was the private IP address which I replaced with my public IP address and port 6000. And then it sees that it's 192.168.1.2 and port 2000. Simply replaces this, creates a new packet, and sends it to the internal system. So you see, NAT did this translation service seamlessly and transparently. The two end stations, they are not even aware of what's actually happening in between. And in this way, if you have multiple internal systems, the NAT can simply replace the internal private IP address with its own public IP address and do this translation. So this way it can support thousands of internal private IP addresses, and you don't even need to buy public IP addresses. So NAT basically supports multiple private IP addresses. It hides the internal network structure, because if an outsider cannot even know the IP addresses of internal systems, then obviously the internal network infrastructure is secure and hidden. And it also does not allow connection initiation from the outside. So based on these three key properties, NAT offers tremendous advantages in terms of reusability of a single public IP address, in terms of hiding internal network structure, and preventing connection initiation from the outside. A related concept with NAT is that of a PAT, or port address translation. Traditionally, what happened was that what NAT did was that it had a pool of public IP addresses, and every time it received a packet from an internal IP, it replaced that with the public IP. So basically, you needed one-to-one mapping. So as many public IP addresses as internal IP addresses. But that defeated the purpose. You see, you'll still require thousands of public IP addresses. So the technique you just observed was technically port address translation, because if you recall, we used port numbers along with the IP addresses. So the NAT generated random port numbers. Now this is also very useful because let's say if one system creates multiple connections to different destinations, then the NAT router can use different port numbers along with the same IP address to differentiate between these multiple connections. A NAT and PAT, they do provide some degree of security. Because they hide the internal IP addresses, they hide the internal network infrastructure, and they prevent connection initiation from the outside. But they do bend a few rules. So there's a trade-off. You see, NAT is a network layer solution. And as you observed, it was accessing and changing transport layer ports. So basically, a lower layer is accessing a higher layer header and changing the ports. So this is theoretically not a good solution. But seeing the tremendous advantages that NAT offers, we do kind of, overlook this small problem. And so NAT is a very popular solution. It's widely used across the world. So that concludes our lecture on NAT. I'll see you in the next lecture.